In this problem, we'll see how to solve a system of equations that contain fractions. Let's look at our helpful hint. First, clear fractions by multiplying the first equation by its LCD and multiplying the second equation by its LCD. Then choose the appropriate method to solve the system. So here's our system of equations that we want to solve. Notice each equation contains fractions. Let's multiply each by its LCD to clear the fractions. In our first equation, our denominators are 3 and 6, so our LCD will be 6. To clear the fractions, we multiply each side by 6. And distributing the 6 on the left side, we'll get 6 times a third is 2. 6 times 5/6 is 5. And on the right, 2 times 6 is 12. For our second equation, the two denominators are both 5, so that is our LCD. Five times 3/5 is 3. So we have 3x. 5 times negative y is negative 5y. And on the right, 5 times 7/5 leaves us 7, and we have got that negative sign, so negative 7. Now we have an equivalent system that contains no fractions. And notice that we can add the equations immediately to get rid of our y variable. We end up with 5x on the left and 5 on the right when we add the equations together. Dividing by 5 gives us x equals 1. So we have found the value of x, we need to find the value of y, and we can use either original equation to find y, or we could use one of our equivalent equations to find y. And of course, it would be easier to use one of our equivalent equations. I'm going to use this first equivalent equation and put 1 in for x and solve that for y. So I'll have 2 times 1 plus 5y equals 12. This is 2 plus 5y equals 12. We can subtract 2, giving us 5y equals 10. And finally, dividing by 5 gives us y equals 2. And we can write the solution as an ordered pair. The solution to the system is 1, 2. Remember, when solving a system of equations with fractions, first clear the fractions, and then use any appropriate method to solve the resulting equivalent system.